Hello, Matthew. All right, are you ready for the last class of COMP-1 or 111, or at least the last meet session? All right, so we do have a few things that we're going to cover tonight and then jump into Lab 5. Um, so were you able to successfully get your Lab 4 worked out? No, well, you probably got pretty close, so um, all right. 8:30 now. We'll go ahead and get started, and hopefully other people will join shortly. So the topics for today are going to be pre and post conditions, static and non-static methods, variable scope, and dependency diagrams. So all things that we've already kind of talked about, we're just elaborating on them. All right, so a precondition. So this is something that has to be true before a method executes. A lot of times this is enforced by data validation, so validating the data inside of the method. So for an example, in the set gender method, we have a character explicit parameter coming in. We would do some data validation on that in gender value to make sure that it was either an M or an F, a valid gender. So you guys also, you already did the precondition stuff in lab 4 with the through num. You were validating that it was a valid number, right, before you did any processing at all. And likewise on the record score, you did a precondition was validating that the whole that the player executed was valid before you actually went through and recorded the score. Okay, so that would be a precondition, making sure that whatever data you're going to dealing with is indeed valid before you actually execute the method. Yes, indeed. Well, you have to define whether, since I work in a health center, we have all sorts of things. So it's, I think it started out being gender at one point in time, but now it's sex versus preferred gender. So I think that's the correct analogy because we need to know, like in the health field, you need to know how someone was born. So what, whether they were considered male or female at birth, because the lab tests produce different, like there's different normal ranges if you were born a man versus you were born a woman. But then we want to be respectful of how someone prefers to be referred to, and so we have a bunch of different identifiers. So yes, it is much more challenging now than it used to be. All right, so here's how that precondition might look where we validate the M and the F before we do any work. So this would be checking the precondition here. Okay, on compute days where we have a date start and a date end, what precondition should exist? So looking at this one, what would be our precondition here? So think about things that have to be true before we even execute this method. So what would have to be true before we even executed this method, seeing the explicit parameters that we have? We would need the dates, and we would want to make sure that those were actually valid dates, right? Somebody could mistype a date in, put a month of 19 or something, right? So we would want to validate the dates. And then if we're computing the number of dates between the start and the end, we would probably want the start date to be less than the end date, right? And then we may even have other parameters that would come into play if it is dealing specifically with something a person has done, maybe this not only does the start date have to be less than the end date, but the start date may need to be greater than their birth date. Like they can't have done something before they got born. So there could be a lot of different preconditions, but at a minimum that these are valid dates. Okay, is minor passing in an age? So what precondition would we look at here? What data validation would we perform on this age explicit parameter? Greater than 0. Yeah, we would not expect someone to be a negative age, so it would have to be greater than 0. And then we might even say maybe it's less than 150 or something like that. So we would look at the age to make sure, or I guess, yeah, less than 150, because if you got this major, if somebody types in 200, then we would assume that they mistyped in the value, right? So we would probably look for some valid range that we would put in there. Okay. Post condition would be something that's true after a method gets done executing. And we've been testing those all along in our JUnit tests, okay? So if we were setting the gender, when we're finished, we would expect this gender contain the new value. So if originally our gender contained an F and then we changed it to an M, we would now expect that the gender would now contain M. Okay, so here we set the gender, we do an assert trues, we're setting it to M. Okay, so we would expect that it would happen, so we assert true, and then we would retrieve the gender and expect it to be equal to M. And we'd have to repeat this for all possible genders and for an invalid gender to properly test the post condition. Because in most cases, the post condition is that it's changing a value, but it could also be that it did not change a value because the gender was invalid. And so you guys have been testing for this all along throughout all of your programs with your assert statements. Okay, so here we have compute days. So our post condition, we would actually expect that this would return us a value that computes the difference between the 2 days. Okay, is minor, if we pass it an age that is less than 18, we would expect this to return us a value of true. And if it's greater than 18, we would expect it to return a value of false. So we would want to test those, and then we would want to test passing some invalid ages as well to make sure that those came back as false. All right, so we've talked before about static variables, and this was way back in, I think, week 3 or week 4, when we talked about constants, and we also talked about a static variable. So we use the final indicator to define a constant, meaning this is the final value contained in this particular variable. But another option is also to define it as static. So if you define a variable as static, it means that the variable belongs to the class, not to the objects that are created from the class, okay? So if we go back to when we create objects and we have instance variables, each object has its own copy of the instance variables. And if object 1 changes the values, it has no effect whatsoever on the instance variables of object 2 or 3 or 4 or 5. A static variable, on the other hand, belongs to the class, and there's just one of them. One version. You can have multiple static variables, but that static variable only exists one time in the class, and every object has access to that one static variable. And so if object 1 modifies the value of that static variable, all the other objects now see that new value. So they can all access the variable. As long as it's not a constant, they can all change the value of that variable, and then they can all access the new changed value. So here's an example of how that's written. Private static integer last assigned num equals 4. So any object created from this class can see that this contains a value of 4, and any object can then update this because it's not a constant. So they can update this value, and then all of the other objects would see the updated value. Okay, so here's another example. We have a customer number defined as static, so public static integer customer number equals 0. And then here we would set our customer number. Then we have a private customer number. Okay, so this belongs to the class and keeps track of the next available customer number. Okay, so we're starting with 0 here, and then this is the instance variable that belongs to the object. So this is what would be assigned to the object itself. And so it would grab this value and add 1 to it and then assign that to our object. So each time a new object gets created, this would get incremented by 1. All right, so for instance, like your student ID numbers at Franklin, and eventually, at one point in time, they started with an initial value, right? And then every time a new student enrolled at Franklin, they got assigned a number. It got incremented by 1. And so that's what this process would do here. Okay, so static variable belongs to the class, and then non-static variables belong to the object. So this one here belongs to the class. This one here belongs to the object. All right, you can also have a static method. So we've talked about static variables before, but you can also have a static method. And this is a method that is not invoked on an object. So it cannot be called from an object, it has to be called directly from the class. And we've actually been doing that in our lab set, right? When you call from the course class has static methods. So the get whole class is a static method that belongs to the course, and it actually, so it's not acted. Nowhere did we create a course object, right? But you could still call the get whole method from the course class. So the get whole method is a static method that any object can call, right? But it doesn't act on an object. It's called directly from the class. Other examples, of course, is the math class, where all of its methods are static and you can call any of its methods by prefixing with math. So math.absolute, math.pow, math.sine, math.cosine, and so on. All right, so we're going to talk a little bit about dots. And you have been seeing dots all along, right? Object name, dot, method name, right? You've been seeing these. Go. You've been seeing these all along. Yeah, everybody, like I said, everybody wants to be right here where I am. Okay, so dots are used as separators. So they separate objects from methods. They separate classes from variable names. So we had the course dot num of wholes. So you have your class dot and then your static constant. So it separates there. You have package names and package and class names and so on. So we have all of these dots that are going on, and they're a separator. Okay, so we can have, here's some examples, java.lang.system.out.println subx. We've got all these dots going on here. So how do you know what is what when you're looking at this particular situation? So for me personally, I'm going to look for opening and closing parentheses, because a method always has open and closing parentheses. They may be empty, meaning there's no explicit parameters, but they're always going to have an open and closing parentheses. So by looking at that, println has an open and closing parenthesis, I can assume this is a method. Okay. A method is called from either an object or from a static class, or a class if it's a static method. But classes, typically, the naming convention for Java is that a class start with a capital letter. And so if we go in front of this method here, we see this out, and it's not starting with a capital letter, so it would be safe to assume that this is an object right here. Okay. If we go in front of that, we do have something with a capital letter system. And again, capital letters are classes, so we could assume this is a class, and because this class is being used to call out, we would assume this is a static class. Okay. And then java.lang is a package that sits in front of all this stuff. So if you're presented something with a whole bunch of dots, narrow in on the parentheses first to find your method. Go right in front of the method. It's either being called by an object or a class, and a class will have a capital letter. Okay. If it's not capital, assume it's an object. If you do see something in there that is a capital letter, you can assume, according to the Java naming conventions, that it is a class. The exception would be as if it's all in caps, the whole thing is in caps, then it's going to be a constant variable, all right? And then stuff in front of that would be your package. let's see. So if we said the java.lang, so Java is the top level, .lang would be a package within this one. So you could say Java using package lang, which is using the class. It almost goes the opposite way. You know what I mean? Like the method, I would almost go from, the method is called from out, print line is being called from out, which is called from system, which is called from lang, which is called from Java. So I almost think it gets read the opposite direction. Yeah, I think from would be better than using. Okay, so here's some examples. If we have import java.util.scanner, and then we define scanner n equals new scanner system.out.println and so on. So if we're looking at this and I wanted you to define all of the methods, you're going to immediately, let's see what my next slide looks like. Okay, here we go. First, look for all the parentheses to see all the methods, okay? So this technically, because we've got the keyword new in front of it, this is going to be a constructor. So a constructor is technically not a method, although I would probably give you credit for identifying it as a method, you know what I mean? But technically a constructor is not a method. But if we look, we have print line, that's a method, or print ln, we have next line, we have another print line, we have a next integer, and we have another print line. So these are all of the methods that we have inside of this section of code. Okay, then we're going to look for the classes because those are usually pretty easy to identify as well because the Java naming convention is that they start with capital letters. So if we look, we have scanner up here at the top, we have scanner, we have system, we have string, we have system, and we have system. So this, our classes that we have here is scanner, system, and string. Those would be the only classes in this section of code. So we've narrowed out the easy things, the methods, and the classes. Okay, next you're going to look for the objects, and objects are called, methods are called from objects, and objects are created from constructors. And then we also have to think of string literals as also an object, right? So we've got in, which is an object because we've got a constructor being called here, creating the scanner object. Okay, we have dot out, which is calling the print line method. We have in name because we're defining a string object, but then there's in calling this method here. Again, out, and then we have a string literal. These two are string literals, so these two are objects. Integer in age is not an object because integer is primitive data, so this would not be an object, but we have in here. Nothing in this line is an object because this is data type double, which is primitive. So dog years is not an object. In age was previously defined up here as integer, so it's not an object. And the literal 7 is not an object. We come down here, out is calling the print line, so it is an object, and we have some string literals, UR and in dog years, so those also would be objects as well. And I guess technically in age was defined up here as an object, so that also is an object. So looking for objects, you want to look for string literals, anything defined, as an object, anything calling a method. Okay, and last you're going to look at the import statements for packages. So we have the java.util package up at the top. Okay, so parentheses identify all of your methods. Capitals identify all of your classes. Then you're looking for what could be an object, not including primitive data or numeric literals, but string literals, and then objects that are defined or used to call methods, and then looking for your import statements. It is actually a special object that belongs to the system class. So it's a special instance of an object. There's other objects in the system class that would be used for other types of output, but yeah. So it's a weird situation. Okay, so that's your dots. Variable scope. Okay, So up till now, we've been talking about local variables. When we've been dealing with variable scope, we haven't really gotten into the full scope. And initially, we just defined a local variable as belonging to a method, right? It belongs to a method. It comes into existence when a method begins executing and then ceases to exist when the method finishes executing. And that is indeed a true statement for local variables that belong to, that are defined at the top part of a method. But the reality is you have to take it a step further when you're defining local variables. A variable scope is actually defined by the curly brackets in which it is created. Okay? So we have lots of curly brackets going on in our classes, right? There's the initial open and closing curly bracket that defines the entire class. So if your variable is defined at that level, it's an instance variable and belongs to the entire class and is therefore accessible to every single method inside of the class. There are the open and closing curly brackets that are defined at the method level. So, you have your method name and then you have an open curly bracket and then you have all your statements and you have a closing curly bracket. So in that case, the variable belongs to the method as a whole. It's local to the method only, and it comes into existence when the method starts executing and ceases to exist when the method finishes. But you can also have curly brackets in your loop. So you can define a variable inside of your loop that's inside of a method, but this variable would be local to the loop only, and it comes into existence when the loop executes and ceases to exist when the loop stops executing. And so it's not available outside of the method. And then your if statements also have curly brackets. So if you define a variable inside of your curly brackets of an if statement, it comes into existence inside of the if statement and then ceases to exist when the if statement stops executing. Yeah, so, it's the scope is really dependent upon those curly brackets. All right, and so here's an example. We have our dog class here, so we're defining two instance variables, kennel and next position. And what you do is you back up and you say, where's the curly bracket in which this is defined? Okay, and so here's the curly bracket here, and here's the closing curly bracket. So the scope of those variables is the entire class. They're instance variables that belong to the entire class. When we get down to get dogs, we actually have an explicit parameter, so this is defined in a method. We also have string output equals and an empty string here. So that is also defined inside this method. So this is where it comes into existence and ceases to exist when the method finishes. So its scope is the entire area of this blue. We then have a loop that defines our I variable inside the for statement of the loop. And we also have this temp dog variable also defined inside of this loop. So it comes into existence here. So there's the opening curly bracket and here's the closing curly bracket. And its existence is the whole generation of this green. And then inside of the loop we have an if statement. So these items would exist up here somewhere, right? This double dog years is defined inside of the if statement. So it comes into existence right here and then ceases to exist right there. So its duration is the yellow. So you really have to pay attention when you're defining local variables, where exactly am I defining them in order to know what their scope would be and where they can be accessed. Okay, so we've talked about preconditions, postconditions, static variables, static methods, dots, and variable scope. We just have one thing left to go, which is the dependency diagrams. Okay, so you have actually been looking at dependency diagrams all along. See the dotted line here with the arrow pointing? Scoreboard demo is dependent upon scoreboard, and scoreboard test is also dependent upon scoreboard. If we were to open up lab 3, which is a much better one to look at, you can see a much bigger dependency diagram. Okay, we have the player test is dependent upon the scorecard. The scorecard is dependent upon the course. The course is dependent upon the whole. The player is dependent upon the course. Yep, the player is dependent upon the course, and the player is dependent upon the scorecard. So to do it dependencies, you're creating a dashed line from the item to the one that it's dependent upon. And so last week we talked about coupling and cohesion, right? So cohesion was keeping a class cohesive, keeping it to a single concept, which is very similar to abstraction, right? And then we talked about coupling, which was the degree to which a class depends upon another, so embedding one class inside of another class. So a dependency diagram is actually showing you coupling, is what it's showing you. So in the course class is dependent upon a whole, because you can, the get whole method will retrieve a whole object. So the course class uses the whole object, okay? Notice the whole object does not have any dependency diagrams. It does not have any arrows pointing to any of these other ones. So the whole stands by itself. The course is dependent upon the whole. The scorecard is dependent upon the course. And the player is dependent both upon the scorecard and the course. So there's references inside the player class to both the scorecard and the course. In the scorecard, there's a reference to course. In course, there's a reference to whole. And that's how you can determine your dependency diagrams. It's actually I can't drag them out. It's not that they're dependent upon themselves. I think it's that the test is dependent upon the player. Because the whole class doesn't create its own. Yeah, I think it's the unit test. All right, okay, so dashed line, arrow pointing from one class to the other. So here we have a customer is dependent upon the address. Like an address doesn't need a customer to be an address, right? It could be the address of a student, of a customer, of a business, of whatever, right, of a house, but it doesn't need the customer to exist as an address. It could exist by itself. But the customer, on the other hand, would have an address, and so it's going to be dependent upon an address class. Okay. So if we assume we have a home business and we want a system that's going to keep track of customers and product inventory, and sales, we could have our sales up here, and the sales will tell you what customer bought the item and what product bought the item. But your customer is not going to be dependent upon a product, okay? And your product likewise is not going to be dependent upon a customer. It's the sales that pulls them all together. So your sales will have like an invoice number and then say this customer bought these products. Okay, but you don't want to say this customer is dependent upon this product, because then each customer would be tied to those specific products, right? And likewise, you don't want to say this product was purchased, is dependent upon the customer, because the product could only exist then if those customers exist. And it could be we have a product that's never ever been purchased, or we have a customer who's never made a purchase. So you want your sales to be dependent upon the customer and to be dependent upon the product. We have a library catalog with all of our books, etc. We need to know our customers. So we would have a catalog that we would create that would contain all of our books. We'd have a customer as well. And then we would have rentals, and the rentals are going to access the catalog to tell us what items can be rented, and then likewise access the items within the catalog and access the customer itself. Okay. All right, and that takes us to the end. So lots of disparate topics there. Do you guys have any questions over them? or any of them for that matter? Yeah, it's things you've been using all along. We just now put some words to them or some formal terminology to them. Yeah. All right, Lab 5. Let's take a look at Lab 5. Typically, students do not find Lab 5 to be as challenging, okay? We're just kind of putting some final touches on things. So, Lab 5, continuing the last time you're going to have to deal, about the final. Oh, great. Thank you, Dylan, for asking me. So, the final can be taken next week. I actually have it available from Saturday. Come on, clock. From Saturday the 28th, and technically you're supposed to finish on Thursday the 2nd. Now, I have done Saturday to Saturday the 28th through the 4th. To take the final. The only reason that they encourage the second is because this last week there's a lot of things that you guys have to complete, right? You've got Lab 5. Well, you've got homework 11 that needs to be completed by Wednesday. You've got Lab 5 that needs to be completed by the end of next week. You've got your reflection paper that also needs to be completed, and you've got your final exam to take. So that means that your instructors for this course have to grade a homework assignment, a reflection paper, a lab, and a final all by Tuesday of the following week. So it's a lot of grading to be done in a very short amount of time, right? So they made the final due on Thursday to allow instructors a longer time, a little bit of leeway that they can then grade the finals and then only have to focus on the reflection papers and the labs at the very end. But I did make it available from Saturday to Saturday, so that way you at least have a weekend to be able to take your final exam. It follows the exact same format as previous weeks, okay? Or I'm sorry, as the midterm. So there'll be true, false, there'll be multiple choice, and then there'll be the short answer and coding. It is comprehensive in the sense that in programming, we can't stop using the things we introduced at the beginning of the class, right? We can't not define a variable. We can't not use an if statement or those sorts of things to do our problems at the end. So it's comprehensive just because in programming, everything builds upon the next item. Now, the focus, however, is going to be on the items that weren't introduced in the last 6 weeks of the course as opposed to the first 6 weeks of the course. In the same manner that I provided you with a study guide and a video, I provided that for the final as well. So if you go out to the course website for the final and click on the icon for the final, down in the discussion area will be the study guide and a video going over the study guide there. 2 hours. The only thing you're allowed to have is scrap paper. And again, you want to notify your proctor, contact your proctor at least 72 hours in advance to verify that they're going to be open. And if you're taking it online, with it's Proctor U, right? They keep changing from one semester to the next, from either Proctor U to Criterion and back again. But the online testing sites do require 72-hour minimum notice. Or I think they charge you like astronomical amounts. So if you're planning on taking it online, you definitely want to get a hold of them and schedule your time. Did that answer all of your questions regarding the final? Oh, goodness. The other thing, reflection paper. So the reflection paper should be an easy, however many points it is. I want to say 50 points. It is not saying how much it is worth, but I'm pretty sure reflection paper is 50 points. Yeah, 50 points. There we go. So the reflection paper should be an easy 50 points. However, well, provided that it's all grammatically and spelling correct, okay? But a reflection paper is not a recitation of the topics that you learned in this course. Okay, I already know that. So reading, 30 versions of the course would not be fun. So what a reflection paper is a reflection of your journey through this course. Okay, so think of it as like a journal or a diary, that sort of a thing. So if you write your reflection paper saying, in week 1, we generated a house in Blue Jay, and that was really cool. And in week 2, we learned about syntax and logic errors. In week 3, we learned about JUnit testing. JUnit testing is blah, 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 blah. Okay, I'm not going to give you 50 points for that. Maximum I'll give you will be 25. And that only counts on if you have written everything spelled and grammatically correct, because that's not a reflection paper. If, on the other hand, you talk about, like, yeah, after I completed lab 1, I really thought I had this and that this class was going to be a breeze. And then along came lab 3, and that was a rude away. You know what I mean? Like, you just kind of talk about your experiences in the class. Or even, we learned about syntax and logic errors, which surprised me. I thought just an error was an error, but now that I understand the difference, I now know why Microsoft is constantly pushing out updates to my computer all the time. You know what I mean? Like, you're not defining anything. You're just kind of talking about your thoughts, maybe how your thoughts changed. Think about your challenges, think about your successes, things you'd like to see changed in the course. Any of that stuff is fair game. What's not fair game is definitions, like no definitions, okay? All right. Any other questions about the reflection paper? All right. There was, and I totally forgot to download the recording, Dylan. So I will do both of those tonight. I was sitting here going, "Where is my?" Usually, I've downloaded it like right after I get done. I start downloading it, but I think it's because my internet crapped out in the middle of the session, and I actually had to go to my phone and finish the meet session over my phone, which I certainly appreciated everybody who stuck around, but it threw me off my game and I forgot to download the recording. So I will do that tonight along with this one. Okay, Lab 5. All right, we are continuing on with our golf situation. We're going to implement a scoreboard class now for our prototype that we've been working on. So scoreboard is going to exist of a bunch of score cards. So if you take a look at this visual of the scoreboard, you can actually see this right here looks like the score card, right? So this is what we're going to do. We're going to implement a whole bunch of these. Okay, so a score board is a collection of score cards. So collection is going to tell you that it's either an array or an array list. And the reality is we used an array when we were dealing with the players with the score card. So we'll be using an array list as we're dealing with the scoreboard. Okay. The first line of the display is going to be the name of the tournament. So you're going to have one instance variable that's going to be the name of the tournament. Okay. And then we're going to have scorecards for each golfer displayed one per line. So each contains the name and the score versus par and so on. Okay. Golfers are added to the scoreboard once they have completed the first hole. So they don't get to be on the scoreboard if they haven't started, if they haven't played any holes yet, only when they complete the first hole. Additional scores are added to the player's scorecard as the player completes the play on the hole. Okay, the scorecard class you've completed is what you're going to use for each one of these. Okay. A golfer who withdraws or is disqualified is removed from the scoreboard. Let's see. And we're going to use an array list of scorecard objects for our scoreboard. You're going to need to be able to find the position of a golfer in the scoreboard. Okay, so if you've got 10 golfers, you want to be able to, and Jones is golfer number 2, you want to be able to find that position in the scoreboard. Well, yeah, exactly. That's what I'm trying to do. There's a lot, but this is very indicative. Like when I'm talking to a user, I get a ton of information from them. Only a little bit of it is actually relevant to what I need to do. And so you have to be able to pick through all the fluff, all the extraneous information that they're providing you in order to know what it is that you need to do. And that's kind of what we're doing here with these Word documents is we're just picking through all this extra stuff to get down to the information that's just needed. Okay. Oh, no two players can have exactly the same name, so we cannot have two players that are named Sam Jones or whatever. Scores are reported. The order of the players needs to be adjusted, which would be a sort algorithm. Okay, for example, if the leading golfer at -3 records a 6, now he's a -1, so he's fallen below second place and we need to change it. So you'll choose which one you want to implement. I think you get to pick whether you want to use an insertion, a selection, or a bubble sort. One of the methods is overloaded, which means that it has the same name. So the remove golfer method, there's 2 of them. They both have the exact same name, but one takes in the name of a golfer and one takes in an integer position. So Java knows which one to execute based upon the explicit parameter that's provided. If an integer value is provided as the explicit parameter, it's going to call the remove golfer method that removes based upon position. And if a string value is passed, it's going to call the remove golfer that expects the player name to be passed. Okay, so here's what we've got. We've got our scoreboard with a string, our constructor that's going to initialize the name, the tournament name, and then initialize your array list to get it ready to use. We have the get tourney and set tourney that's set and get the name of the tournament. The number of golfers, which is going to be the number of item elements that you've added to your array list, right? We're going to be able to find a golfer based upon the name of the golfer, add a new golfer and record the score of the hole. Here we have another record golfer score, which is just going to call the record score in the scorecard class. Remove golfer, one giving us the position, one giving us the name. So they've been disqualified or something, so they're getting removed. And then the get scorecard, the sort versus par, and then the toString. Okay. We've got some exceptions. So in the find golfer, if there's no golfer that matches, you're going to return this value not found. So that's a constant you're going to have. Adding the golfer, if the golfer already exists with that name because it has to be unique, you're going to return false. Removing golfer, if the golfer is out of bounds or the golfer is not in the condition, you're going to remove false or return false. And if you're recording the score and the golfer is not in the collection or the return score of the scorecard returns false, then you're going to return false as well. If you're calling the get score method and the position is out of bounds, you're just going to return a null value. Okay, so keep this handy. Lots of good information in there. So let's take a look at the scoreboard. Okay, testing. So we've got some setup. Again, we're building our course with six hole golf course. We are actually creating a scoreboard object here called Moorfield Invitational. We are adding some golfers to this scoreboard. So we've got Nicholas, Woods, Sorenston, and Ochoa. And let's see, the add golfer method. What else does it have in it? The name of the golfer and the score on the first hole. So a golfer can only be added if they've actually played a hole, right? So this is the name of the golfer and their score on the first hole. So we've added the golfer here, and then we're recording a second score. So both Nicholas and Woods have played hole number 2 as well as hole number 1. So we're doing calling record golfer score to record their score on hole number 2. We've got a couple more golfers, Lopez and Watson, and then we're recording the scores on hole number 2 for Sorenstan and Ochoa, and hole number 3 for Nicholas and Woods. So Nicholas and Woods have played holes 1, 2, and 3. Sorenstan and Ochoa have played holes 1 and 2, and Lopez and Watson have only played holes 1. So this is just some information that's provided for you to be able to do some testing. Testing the constructor, create the object that you're testing. So call the scoreboard, passing it Moorfield open. Okay. Do an assert not null. Make sure it's been created, and then you need to test the instance variables. So here we're testing the tourney to make sure that it did set the name of the tournament to Moorfield Open, and we're testing the number of golfers. Okay. Set the tourney name. So we create our object, so then you guys know what you should test at this point. You need to call the set method and then call the get method to verify that it's changed, and changing it to something other than Moorfield Open. Adding a golfer. Okay, so this test case has been provided for you, which is wonderful. So again, we create our object here. We add a golfer, Watson, and he scored a 4. 4 on hole number 1. I'm not clicking in here, which makes me curious why that's happening. And then we check and we call the find golfer. So if he's the first one added, he should be added to element position 0. So we then check, does Watson exist, and did it give me a 0? And then we check the number of golfers because it should be increased by 1. And then we add 2 more golfers, Kerr and Ochoa, and we check, is Kerr in position 1, which is where he should be, is Ochoa in position 2, and now I should have 3 golfers. And then we try a final golfer here, so we're checking for Nicholas. We did not add Nicholas to our golf course, right? We added Watson, Kerr, and Ochoa to this version of the scoreboard, so we're checking for Nicholas, and Nicholas, since he doesn't exist, should return the not found, so we're calling this static variable scoreboard.notfound. And this is just not replying to me, so I'm going to close it down and open it back up again. All right, so that was the add golfer. Okay, remove golfer by position. So to remove a golfer, it means that you first have to add some golfers. So this is actually using the board 2 instance that was up in the setup area. So it found golfer Woods, and that's in position 1. So went up there and looked. So first we added Nicholas and then Woods and then Sorenstam and Ochoa and then whatever the other ones were. Okay, so it goes find me golfer Woods. So that would be in position 1. So that golfer does indeed exist. And then it retrieved the count of the number of golfers, which should be 6 because it added 6 golfers up there in the setup area. Then it removed the golfer at position 1, which should be Woods, right? Removed golfer 1, expecting a value of true. And then you need to test to see, was the golfer actually removed? So what's some tests that we could do here to see if this golfer was actually removed? So taking a look at this where we added a golfer, what are some things that we could call after we said remove Woods? What could we call to check and make sure that it's actually been removed? Yeah, you could definitely call the get num of the golfer. So find the golfer, I guess. We'll get number of golfers because that should be reduced by 1. And then you could definitely call the find golfer, passing it the name of Woods, and you would expect it to return you this scoreboard not found if it's been successfully removed, right? Okay, so you're going to call those 2 methods to check and see if it's moved. And then you're going to also try to remove a golfer that doesn't exist. Maybe give it a -1 as your position or a 10 as your position, right? And then check to make sure that the count is not reduced and that it returns a false. So it should do an assert false when you try to remove a golfer at position -1, and the count should not be reduced. So removing by name, your tests really go along the same way. You're going to call the find golfer and get the number of golfers here so that you have that information. Then you're going to call the remove golfer, but this time you're passing it the name of Woods as opposed to the position, right? So you'll pass it the name of Woods, and then you're going to run through the same test cases that you just did. Call the find golfer, make sure it returns you a not found, call the count, and make sure it's been reduced by 1. Okay, getting the scorecard. Looks like they've given you all the test cases for that, so you don't need to worry about that. This one is not finished, the record golfer score. So they're recording a score for Woods. So Woods had played holes 1, 2, and 3. So they're recording the scores for 4 and 5. And then they're doing a find golfer Woods. So they're getting the scorecard for Woods. And then they're checking for his score on 4, which was just recorded as 6, and checking for his score on hole 5, which was just recorded as 4. So then you need to check for some invalid attempts to record the score. And remember, the score has to be in order. So you have the last 2 golfers, what were they, Ochoa and whatever, the very last 2 golfers only played holes 1 and 1 or 1 and 2, right? So when you're recording a score, it has to be in order. So you could take Nicholas, who has played holes 1, 2, and 3, and try to record hole 5, and that should be invalid, and check that out, make sure that that does not record his score. Or you could go with the other golfers that have only played 1 hole or 2 hole and try to record hole 4 or 5, or try to record a score for a golfer that doesn't exist at all, like put your name in there and just make sure that it processes correctly. Okay, for the sort, they've looked at the golfers and made sure they're in order 0, 1, 2, 3, 4, and 5. Then they call the sort, and based upon what scores have been recorded, Sorenstam should be in position 0, and then they look for Woods, Ochoa, and Watson, and they make sure that they have the correct values here, okay, that they're in the correct positions. Then they check the last two golfers. They're tied. So then they are just Nicholas and Lopez. Ochoa gets taken out, and then they record some additional scores. They call the sort again, and your job is to write the test cases to now make sure that this is in the correct order. And the two string is good as it stands. All right, test cases. Writing the class itself. Okay, so not found is already defined for you. You've got this constant not found. It's static. It belongs to the class. Okay, and it's public. So that's why we were able to reference the not found here, because it's public. It's not defined as private. Okay. We have two instance variables, the string variable, which is the name of the tournament, and then our array list that is going to contain scorecard objects. Okay, but there's no equal sign here, so memory has been set aside for these guys, but they currently contain a null value, so they're not usable. In your scoreboard class, you're going to assign your tournament instance variable to your explicit parameter, and you're going to finish the definition of your array list as in this dot board equals. Okay, make sure you're using this dot board equals so that you're referencing this instance variable. If you start out with the whole array list scorecard, right, board equals, then you are defining a brand new local variable that belongs to the constructor only and will cease to exist as soon as the constructor finishes. So you want to start with this, and you'll end up with a whole bunch of null pointer errors, all right? So you want to start with this dot board equals. Okay, get and set of the tourney should be pretty straightforward. Get the number of golfers should be pretty straightforward. It's the size of the array list. So you're just going to return, call the size method of your array list instance variable and return that value. Find golfer. So we're looking for a golfer. Now this is going to get a little bit complicated because where does the golfer exist? In the scorecard. And where do our scorecards exist? In the board, right. So you're going to have to loop through the array. Well, I'm not going to spell tonight, guys, so as if I spell well any day, but you're going to loop through your array list board, start to finish, okay? Then you're in, so, and then you're going to get the value. You're going to need to get your scorecard, so maybe you create a temporary, so you're inside of your loop here, okay? So you're going to create a scorecard object. Scorecard equals, well, whatever, temp card or whatever you want to call it. Temp card equals this dot board dot get sub whatever your loop variable is. Okay, so you're inside that array. You retrieve the scorecard. Now you've got the scorecard, but that's not enough. You got the scorecard, now you got to get the name. So then you're going to have to do a string name equals, you know, temp card dot and call whatever method it is in the scorecard class that will get you the name of that player. And then when you have the name of your player, then you can check to see if your instance variable name is equal to your temp card name that you just retrieved, right? Don't call this name then, because you'll have two things with the word name in there. Okay, so temp name, but it's string, so how are we going to compare these two guys? Are we going to use the equals for comparison? Right, we're going to either have to use dot equals or dot equals ignore case. Okay, so if they are equal, then inside of here, just return whatever your I is, because you found the golfer if they are indeed equal. And if they're not equal, then this return not found should be down here at the end of your loop. So you're going to loop through your array list. For each element in the array list, you're going to retrieve the scorecard at position I, okay? Then you're going to call the get player name method on your scorecard object, and then with that, you're going to compare that against your explicit parameter here, and if they are indeed equal, return value I because you have found your golfer, right? Okay. Adding a golfer. So you can only add a golfer if the golfer's name does not exist. True? Did we just write a method that will tell us if a golfer exists? Yeah, so don't reinvent the wheel here, right? What you're going to do is you'll call this, so you can say if this dot, whatever this method name is up here, get golf or find golfer. If this dot find golfer, and we know the name, right there, some name, if it equals that not found thing, then you're going to return false. I like to get rid of these things first. So if it equals the not found constant, then just return your false. Okay. When we're done, we're out because it's not valid. So if we're here, then that means it was, or if it's not equal, I'm sorry, if it's not equal to not found, that means it already exists. So if it's not equal to the not found constant, then return false. The golfer already exists in there. We're not allowed to add it. So if it wasn't found in there, then we need to create a scorecard object. So you're going to have to call your scorecard, and maybe you call it temp card equals new scorecard. And then you're going to need to know whatever your constructor is so that you can put the value here, right? So whatever your constructor is, so I think it takes in a player name, and you know what that is. And then before you're done, you need to do a temp card.record score. What whole number does this guy just play? If we're adding a golfer, what whole number have they played? 1. So 1, and then your score here that we've got up here. Okay. Oh, what did I just do? So score goes here. Take a look at that record score method in your scorecard. So now we've got our card, and now we can add it to our array. This dot board, should spell it right, board dot add, and then you're giving it your card object. All right. 931. Let's see if we can work through these. Removing the golfer. So we need to remove a golfer at this position. So precondition, that position needs to be valid. So you need to validate the position, which means it's got to be greater than or equal to 0 and less than the size, right? And if it is, then just call the array list remove to get rid of this position. Easy peasy for that case. For this one, removing the golfer based upon a name, they've actually done this for you. So they find the golfer, giving it a name, and then they just call this dot remove because this is going to give me the position, right? And then it calls this method to remove it, giving it the position. Get scorecard. So on this get scorecard, you need to, you're at this particular position, again, make sure the position is valid. So this kind of tells you what you need to do for up here to validate your position, right? You're going to return null if it's not a valid position. Otherwise, you're going to retrieve the scorecard at that particular position, but you're not going to return, just return it. You need to create a copy of it and return the copy. And I talked about this on Piazza today. So if you look at the Piazza post for today, it'll give you a little bit more information as to how to complete this particular method. But we're creating a temporary scorecard class, passing it in the name. Now you're going to need to go through So we've got this found card here that we've got out of the array list. We're creating an exact copy of it here, just a different location in memory. So we've got the card. Now you're going to need to loop through all the scores um, that are exist inside this found card and add them all to this scorecard here. Okay, so you want to pull up your scorecard class to figure out how to do that. Recording a golfer score, the name of the golfer, the hole, and the score. This is just calling the method in our scorecard class. So again, call your find golfer to get your array list element. And then on that, you'll have a scorecard object then, and you can call the record score on that scorecard object. So again, look at your record score. Sorting by par. So go back to week 9. I went through all of those sort algorithms for you, right? And in particular, I spent a lot of time on the bubble sort, showing you how you can use the bubble sort to sort objects. And I used it with regards to the dog class, showing you how we could use the dog class and we have to call the get age and so on. So this is what you're going to need to do here in order to sort the golfers in the correct order. So you're going to pull out one of those sort algorithms, your choice, which one you pick, and then you're going to need to drill down into to get the versus par information, and that should be available in the scorecard class. Let me pull up that scorecard class. So remember, in your plus libs, we can come into the docs folder to get the Java docs. So we can compute versus par through a number, right? We just wrote that in lab 4. So you can, on the scorecard, you can do a compute versus par. So you're first going to have to get the holes that are played and then supply that as your through number to know what the player's score is. And this will, you can call this to get your number of whatever their score is. So in this, you're going to have that whole sort algorithm, right? And remember I said that just that if statement is the part that needs to be modified, but you need to know how to do that if statement. So you're doing some sort of loopy thing going on here. Go back to the algorithms to find out what that is. And then at this point, you've got your scorecard. So again, you're going to do your scorecard temp card equals, this dot board dot get sub I, right? And then you're going to do this exact same thing all over again, but it's going to be the I plus 1. Right? Because you're going to be comparing what's at I to position I plus 1. So this would be like temp card 1 and temp card 2. Okay, then you're going to need to get how many holes has the player in temp card 1 played. So you're going to need to get that. So integer, holes 1 equals temp card 1 dot get holes played. Right? And that'll tell you how many holes this guy's played. And then we're going to compute our strokes. Our compute versus par returns also an integer value. So integer par 1 equals temp card 1 dot compute whatever it is called versus par. And that takes in a hole. And we know how many holes they played because we just got that. Hole 1. Okay, then you need to do the exact same thing for our temp card 2 to get that value. And now you can do if par 1 is less than par 2 or whatever and determine whether you need to sort things or not. This guy's written for you, thank goodness. Okay, that is lab 5. So key methods. When you're working on this, again, take it in pieces, right? This guy here is key, right? This find golfer. Because we just use that over and over and over again, right? We use the find golfer to determine if we're going to add a golfer. We use the find golfer to find the golfer to remove it by the name. We use the find golfer, I think we use it in here, yeah, found card.get name. You know what I mean? So we're using it over and over again. Well, we use it here in the record golfer. So we're using it over and over again. So key method, make sure you get that one working first before you start working on anything else. So start initially, get your constructor working, set and get it the tourney name, number of golfers is pretty straightforward, and then find, well, you have to be able to add a golfer before you can check to see if you found a golfer. So add a golfer and find golfer, they're kind of include or dependent upon each other. So get that working. Add golfer up. Get those things working first. Once you know those guys are working, then you can work on the two remove golfer methods down here at the bottom and get those working. Then work on your scorecard, get scorecard here, and record the score. Okay, save the sort versus par for very last. And again, when you're working on the sort, go back to the meet session from week 9 where I went over all of those. You can pull up the PowerPoint or watch the recording again. But I went over all the different algorithms and specifically the bubble sort, how you can use it in retrieving different sort of data. Okay, so I ran way over, guys. I'm sorry about that. But hopefully this gives you a good foundation for working on Lab 5. Good luck on the final next week. And I think that's all we got. All right. If you run any questions, don't hesitate to send me an email, and I'll definitely be watching